So the coefficients in a balanced chemical equation provide us mole ratios of the reactants and products. So here we're with nitrogen and oxygen again, but this is a slightly different reaction. In terms of moles, this says 1 mole of nitrogen reacts with 1 mole of oxygen to make 2 moles of no, right? So we can answer questions like this. How many moles of oxygen would react with 2.25 moles of nitrogen? What do you think? If we have 1 mole of nitrogen, it takes 1 mole of oxygen. If we have 2.25 moles of nitrogen, it would take how many moles of oxygen? 2.25. We have a 1-to-1 ratio here, and so we can just kind of think about this one and have it work out. But of course, it's not always going to be like that. We can actually form unit factors from the balanced chemical equation. And so what I'd like you to do in answering a question like this is think of it in terms of dimensional analysis, unit analysis. 2.25 moles of nitrogen. The question is, how many moles of oxygen? So that's the unit I want to find. I multiply by that. This is the unit I have. I divide by that. And I see that my units cancel out, right? We put the units in first, and then we look for numbers. The numbers come from the balanced chemical equation. The number in front of nitrogen and the number in front of oxygen. There is 1 mole of nitrogen for every 1 mole of oxygen. So it's 1 and 1, and we come up with 2.25 moles of oxygen, which is what we figured out just by thinking about it. You might say, well, that's an awful lot of work for something I can just look at. But it's helpful to try something like this where you can figure out the answer and check yourself as well. Any questions about what I did there? Let's look at this one. Iron is produced from iron ore in a blast furnace by passing carbon monoxide gas through molten iron 3 oxide. Fabulous. The balanced chemical equation is right here. That's great. That's the part we need. All that stuff up there is just fluff. How many moles of carbon monoxide react with 2.5 moles of Fe2O3? Someone says 3. No, I don't think so. Oops. Let's let the units tell us what to do. 2.50 moles of Fe2O3. And we want to know how many moles of CO, carbon monoxide. What unit should I put in the denominator? Moles of Fe2O3. Because I want this unit to go away. That's not the unit I want. This is the unit I want. So that would make this cancel out. The ratio here comes from the equation. What number is in front of Fe2O3? 1. So down here in front of Fe2O3, I'm going to put 1. What's in front of CO? 3. So I'm going to put a 3 here. 2.5 times 3, I believe, is 7.5. Does that make sense? If I had 1 mole of Fe2O3, 3 moles of CO would react. But I've got more than that. I've got 2.5. So I need to multiply by 3. It's hard to keep track of should I multiply or should I divide. But if you write it out like this, you don't have to think about that. You put the units in, you copy the numbers down with the same chemical, and it tells you what to do. I think it's beautiful. You may think it's a crock, but I like it. So So this one, how many moles of iron are produced from 2.5 moles of Fe2O3? We're going to do the same thing. 2.50 moles of Fe2O3. What unit do I want on the numerator? Moles of iron. And then I want moles of Fe2O3 in the denominator. So that cancels out. What number goes right here? 2. And what number goes on the bottom? 1. And so we get, 5 moles. Oh, I lost a sig fig up there. 5 moles of iron. Should be a 0 in here. Any questions? We can make a relationship between the two reactants, between the two products. They could give us an amount of product and ask us for a reactant. They could give us a reactant and ask us for a product. You can do mole relationships between any two reactants or products with one step. And it all comes from the balanced chemical equation.